Alright, good morning everybody. Welcome to Monday, second full week of school. So continuing on with chapter 1. So this is 1.4, perimeter and area. In coordinate plane. So it starts off with a few questions that they're just kind of classifying polygons. And a polygon is just another word for a shape. Really, it's just a general form for something that has sides. So when you hear the word polygon, it's just talking about a shape. So there is, I'm not going to write it down, but on page 30 in the book, there's a chart that has the number of sides and then what that polygon is called. So 3 is a triangle, 4 is a quadrilateral, 5 is a pentagon, 6 is a hexagon, 7 sides is a heptagon, 8 sides octagon, 9 sides nonagon, 10 sides decagon. They skip 11. I don't know if there's a name for an 11-sided figure or not. Maybe you want to Google it if you're curious. 12 is a dodecagon. And anything after that, we legit just say an N, like the letter N, gone. And what that means is if it was like 15 sides, you would call it a 15 gone. If it was 20 sides, you'd say a 20 gone. You just use the number. So it's going to ask you to classify a polygon, and you're going to use that word. What are the corresponding words? 5 sides. You're going to say it's pentagon. But then it's also going to ask you for convex or concave. So the way that the book does it, and it doesn't matter which way, but if you say you're going to say convex or concave first, and then the actual name of the polygon. No, it actually does it both ways, so it really doesn't matter. Okay, so what the heck is convex versus concave? Convex kind of means that there's no like kind of cavities. That's the way like I think of it. Like this would be convex, and this would be concave because you have this little like space right here. I literally think of it like, could I pour water and like it's gonna sit somewhere, and I could pour water like in here and it would sit. No matter how I spun, this one, it's just going to fall off the side. Nothing's going to hold itself. So concave, there's a little cave there, however you want to like kind of remember it. So, but keep in mind you can turn the shape, so if I poured one on the top, it'd fall off the edge, but if I spun it, then the water could fit like on the top. So I think in the book it talks about if you connected corners. So over here on this one, if I connected corners together, they always cross on the inside, no matter like what direction like I go. Creates a star. But on this one, if I connected the corners, it goes on the outside. So I think the book talks more about like interior crossing on the inside or the outside. So you'll have just a couple problems that'll say classify the polygon. You're going to use one of the words from the chart on page 30, triangle, quadrilateral, pentagon, hexagon, and so forth, and then convex or concave. Okay. Then we'll get into the perimeter and area stuff. So, all right. So perimeter, I think we all understand, hopefully, but so it's just around the outside. I put this just because you're always going to be adding when you do perimeter. And then area is on the inside. And pretty much all the area formulas you're going to be multiplying. So really we're just going to primarily deal with a triangle. And so remember that area is 1/2 base times height. And then just like any square or rectangle, it's just base times height. Okay, so let's look at a couple of examples of triangles, or the harder ones. So if I had a triangle that had these coordinates, so you're going to need to graph some of these in order to do the work. And depending on the triangle, it's usually, well, I suppose I could draw one that would be hard to do both perimeter and area, but so -2, 3, and 3, -3, and -2, -3. So this one, to do perimeter, it's nice that we have two of the sides, one of them goes straight up and down and one of them goes straight sideways. So to do perimeter, you can just count the spaces. So from this top point up here to the bottom point down here, if you count the spaces, you go 1, 2, 3, 4, 5, 6. And over here you go 1, 2, 3, 4, 5. So two of the sides for perimeter, nice and easy. Third side, when it's on a diagonal, then we need to do either the distance formula that we did last week, or I think it's super easy from this point to just do the Pythagorean Theorem. I have A and B right now. So if I did 6 squared plus 5 squared equals c squared, then I get 36 plus 25 is 71. And then I do the square root. So 71, let me see. Square root of 64 is 8. And the square root, 9 times 9 is 81. So where does 71 fit in there? Well, it's 10 numbers away from the 81, but it's only 7 numbers away from the 64, so it's closer to the 64. So it's probably going to be it's a little bit closer to the 64, so it's probably going to be like 8.4. And as long as you're within like if you said 8.3, you're fine. Okay, it's actually probably more like 8.3 now that I think about it, but as long as you're 0.1 off, you're fine. So 6 plus 5 is 11. 11 plus 8 is 19.4. Except for stupid me, I added wrong all the way back here, so let's erase all that. Sorry about that, guys. This should be 61. So I would still do the same thing, like 64 is square root of 8, and 49 is 7. So it's almost to 64, so probably 7.8, maybe 7.9. Again, if you're off by just a point, you're good. Alright, so 11 and 7 is 18.8. Okay, so there would be perimeter. Sorry about the calculation error there. Alright, and then for area on this one, it's a lot easier because it's half the base and the height are just the 5 and the 6 because they're straight up and down and sideways. So a much easier problem to do area. So you can do half. Well, I always just kind of do half of either of them. So I would do half of 6 is 3 times 5 is 15. Okay, so usually if the perimeter one is a little bit harder, the area one is a little bit easier. But it just kind of depends on the problem. Okay, so alright, so let's look at another one that's a little bit more advanced, I guess. It's got a little bit more to it. So if we had 1, 3, 4, negative 3, and negative 4, negative 3. So 1, 3, 4, negative 3, and negative 4, negative 3. So if you had graph paper, that's obviously the best when we have to do any of this graphing. You could also, so if you're making a graph on your piece of paper, I for sure put like the x-axis right here, like on one of the lines, and then each like blue line on your line paper, I would go up, like counts as 2. So I'll erase this in a second, but like I would have a blue line go there, and you can estimate the one in between. I'd have a blue line go there. You could estimate the negative one in between. I wouldn't go any smaller than that. If you do, you can actually do the problem correctly and get the wrong answer just because everything is so condensed. If the numbers are small like these, you could do it where each blue line counts as 1. You can always go bigger, but okay, so perimeter. Okay, the bottom one should be easy. Just count 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the bottom is 8. And now it gets a little tricky because we got to figure out these other two sides that are on an angle. Okay, so if I label these, and I probably should have done it at the beginning, but A, B, and C. So from B to C, how long is that? From A to B, how long is that? So I'm going to come back to that because I'm going to draw a bunch of stuff here in a second, but I'm going to skip to area. Okay, so half base times height. The base is 8. And then the height is always from the top straight down. So here's our height. Doesn't have to be a side of the triangle, but it's from the top straight down. So I can just count. Like that's kind of a nice thing when we have a flat edge, like from A to C is flat. If it's not flat, I can't just count, but you won't have any like that. They'll all be flat on some part of it. So if I count, I go down 1, 2, 3, 4, 5, 6. So that red part is 6. Okay, so when I multiply here, I get to do half of one of the numbers. It doesn't matter which one, but there's only one fraction there. There's only one half, so I can't do half of 8 and half of 6. I just do half of one of them. So 4 times 6, 24. All right, so going back to perimeter, and the reason I kind of left is I want to use that 6. Okay, because I'm going to do Pythagorean Theorem. So over here, if I kind of sectioned off that bottom part, to the right side, I'd have 1, 2, 3, and that means over here, I have 5, because the whole thing is 8. So with the right triangle, or the BC part, I can do Pythagorean Theorem. I have a 6 and a 3, so 6 squared plus 3 squared, 36 plus 9, 45. So to estimate square root of 9, or excuse me, square root of 7 is 49. If you wanted to just use a calculator, that's fine to do the square root. But you could do the, like I kind of suggested, square root of 49 is 7, square root of 36 is 6, so 45 is probably in that 7, or 6, it's not going to be 7 because 7 is all the way up to 49, probably 6.8. Let's see if I do it in the calculator. 45 square root 6.7, I was off. So when we do the square root, remember I was only off by 1. So 6.7. So as long as you're only off by 1, I'm good. Especially if you're estimating. But if you just use a calculator, it's fine. Okay. On the other one, the AB part, okay, so this is the BC length. So the AB part, I would have 5 squared plus 6 squared. So 25 plus 36 is 61. Square root, we just did that on the first example. Excuse me. So 7.8. This is the AB. And then add those up. So, you know, I'm able to do this kind of stuff in my head, but 8 and 6 is 14. 14 and 7 is 21. 21.7, and then another 0.8 gives me up to 0.5. So however you need to add those up. And again, if you check your answer in the back of the book, and it says that the answer is 22.4, or even 22.3, because if you're 0.1 off on the first one and 0.1 off on the second one, then you could be off as much as 0.2. But if you're that close, you did the problem right. It just has to do with rounding. Okay. All right. So you'll have, like I said, the convex, concave, and then is it a triangle, an octagon? Like, what is it? You'll have some that are just perimeter. You'll have, then you'll have some that are just area. And then at the end, you'll have a figure that's already graphed for you. And some of the questions will ask you to find the perimeter of this one, and some will say find the area of that one from the picture. Okay? So, like I said, if you want to, if you have graph paper, this is a good assignment to use graph paper on, but you don't have to have it. You don't need to run out to the store and buy it. Just make an accurate graph to the best of your ability, and the bigger you make the graph, the better. So, like I said, if you put the x-axis on a line on your paper, and then the next line up is where 2 would be, and then 4 and 6 and so on. That way you can just estimate in the middle, but every 2, you're going to be perfect. Okay? So on these, a lot of work. I mean, look at this is one. I mean, you won't have to do area and perimeter, but you can see, like, especially the perimeter ones, there's a lot of work to show. So not like early in the chapter where it was just kind of like, here's the answer. So make sure you're writing down your work. On these ones, because there is so much work to show, you don't need to write the problem down. Or draw the picture rather. So if it's just a list of points, write those points down. But if it's a picture that you're going to work from, don't worry about drawing the picture, just do your work. Okay? All right, have a great rest of your day. Keep pushing forward. Okay, remember, we'll come back to all this stuff again after today just to review it again, but keep pushing forward. Get those assignments in. All right, have a great day. See ya.